Hello grade 11, welcome again with you Mrs. Minna Raouf, your chemistry teacher. Today we will continue chapter 20, chemical reactions and energy. And section 2 is talking about measuring energy changes. In the last session we talked about the two types of chemical energy that depends on heat: endothermic reaction and exothermic reaction. And the difference between endothermic and exothermic is that exothermic release energy and endothermic absorb heat energy. But now we will talk about how measure energy changes. First, when you read the title calorimetry, what do you remember? What are related words you can remember? Yes, calorie. So the first word in your mind is calorie, and the calorie is the unit used to measure the amount of energy in food. So the calorimetry is a technique used to measure the heat generated in a chemical reactions, and this is by using a device called calorimeter. So the device that we use to measure the heat generated in the chemical reaction called calorimeter. This figure that shows the structure of calorimeter, and this is called bomb calorimeter, that used by food chemists, which consists of a bomb, and this bomb contains the sample that required for the chemical reaction and oxygen, and surrounded by water. In case of the endothermic reaction, the surrounding water in the calorimeter supplies the heat and decrease in temperature. The heat lost or gained by the surrounding water is calculated by equation QW equal M delta T CW. What each of sample refers to: QW is refers to the heat absorbed by water, M is refers to the mass of the water, delta T, and I told you before that is delta means the change, and here delta T is the change of temperature for water, and CW is a specific heat of water which is constant, equal 41.84 joules per gram degree Celsius. So our equation that we use to calculate the heat lost or gained by a reaction is equal heat of mass delta T times CW. We know before that the law of conservation of energy states that there is no net creation or destruction of energy. So the heat absorbed or released by water has been released or absorbed by the reaction. So when we talk about the heat of the reaction, this stands for the heat change of the reaction. So we can say that the heat lost by the reaction mean this heat gain for the water, and the heat gain for the reaction mean heat loss for the water. So we can calculate the heat of reaction that is equal the negative of the heat of the water. So Q reaction equal negative Q water. Now how to calculate the heat of reaction for combustion? Okay, let's solve this problem together. The burning of 1.6 gram of methane in oxygen to yield carbon dioxide gas and liquid water causes the surrounding 1.52 kilogram of water in the calorimeter to change in temperature from 20 degrees Celsius to 34 degrees Celsius. What is the heat of reaction for this combustion of 1 mole of methane? So he wants to calculate the heat of the reaction, but for only 1 mole of methane. Okay, let's first calculate the heat of reaction. I told you that we use the equation that is heat of water equal mass delta T times the specific heat of water, QW equal M delta T CW. First we need to calculate delta T, and delta T is a change in temperature of water, and delta T is equal T final minus T initial. So it will be 34 minus 20 equal 14 degree. So by replacing the given numbers in the equation, the heat of water is equal 1.5 times 10 power 3. We need to change the mass from kilogram to grams. So we will make multiplication by 1000. So 1.5 times 10 power 3 times 14, and 14 is the delta T, represent delta T, times the specific heat of water 4.184. So it will be equal 8.9 times 10 power 4 joule. We will convert now it to kilojoule, so we will divide it by 1000, so it will be equal 89 kilojoule. This is the heat of water. So we can now calculate the heat of reaction that equal negative the heat of water. So it will be negative 89 kilojoule. And this is the heat realized by burning 1.6 gram of methane. Now we wanted to calculate the heat of the reaction just for 1 mole of methane. So we must calculate the number of moles that found in 1.6 gram of methane. By using magic triangle 1 from quarter 3, we first must know that the structure of methane is equal CH4. So the number of moles, we know that the number of moles equal mass divided by the molar mass, and the mass here is equal 1.6, and the molar mass will calculated by the following: carbon molar mass equal 12, and hydrogen molar mass equal 1, and 1 times 4 equal 4, plus 12 equal 16. So this is the molar mass of methane. So 1.6 divided by 16 equal 0.1 moles. So the heat of reaction will equal minus 89 divided by 0.1 equal minus 890 kilojoule per mole of methane. So now we just make replace for the given number in our problem by using the equations that the heat of water equal mass delta T times the specific heat of water. Now let's talk about the energy value of food. Chemists measured heat in calories instead of joules, and a calorie is the heat required to rise the temperature of 1 gram of liquid water by 1 degree Celsius. And a kilocalorie is a unit equal to 1000 calorie, and 1 calorie is equal to 4.184 joule, and the 1 joule is equal to 0.239 calorie. So 1 food calorie is the same as 1 kilocalorie. So 1 food calorie is also equal to 4.184 kilojoule. The food contains a variety of chemical compounds that can be grouped into 3 general types: protein, carbohydrate, and fats. And they have different energy contents. For example, the fat provide about 9 calories per gram, but the carbohydrates and proteins provide about 4 calories per gram. And this table shows the caloric value of some food. A quantity of 1 tablespoon of butter equal 100 calories, and 1 tablespoon of peanut butter, which is equal 16 gram, is also equal 100 calories, and 84 gram of beef is equal 241 calories. The chemical compound in the food you eat provide you with energy, and these compounds undergo slow combustion and combining with oxygen to produce waste products, carbon dioxide, and water. So your body needs these compounds to growth and development. Now let's show together how to calculate the food calories. For example, A 1 gram sample of nuts react with excess oxygen in a calorimeter. The calorimeter contains 1 kilogram of water that has an initial temperature of 15.4 and final temperature of 20.2 degrees. Find the energy content of nuts and express your answer in kilojoule per gram and calories per gram. So first, we will replace the given number in our equation that states that the heat of water is equal mass delta T Cw. So by using Qw equal m delta T Cw, first we will calculate the change in temperature that equal 20.2 degree minus 15.4 that equal 4.8 degree, and then replace the given number in our equation that equal 1 times 10 power 3. As I told you before, that we must change the mass of water from kilogram to gram. So Qw equal 1 times 10 power 3 times 4.8, and 4.8 is equal delta T times 4.184 that equal the Cw. All of that equal 2.01 times 10 power 4 joule. This is the amount of heat expressed by joule. So we'll make a division by 1000. It will be equal 20.1 kilojoules. This is the energy. So this is the energy expressed by the kilojoule. So we must now change it or convert it from kilojoule per gram to calories. So we'll divide the amount of energy by 4.148. So 20.1 divided by 4.184 will equal 4.8 calories per gram. So now we can measure the amount of calories in our food. Now let's talk about energy economics. Why recycling has become so important? Because the energy required for recycling a used object is less than the energy required for making new ones from fresh raw material. So the recycling is very important because it needs energy less than the energy required for making a new object from fresh raw materials. For example, aluminum production and recycling. The production of aluminum requires large amount of energy, and we use electrical energy. Therefore, one reason to recycle aluminum that is to conserve the energy and reduce the cost of producing aluminum products. So what's the important for the recycling of aluminum? That is to conserve the energy and reduce the cost of producing aluminum products. We have many aluminum products that we use every day. The soft drink cans and other objects that show here in this figure are all made from aluminum. For example, the amount of energy required to produce cans from recycled aluminum is about 15 to 20 cans. It's the same that used for made only one can from the aluminum ore. Now, how we convert the chemical energy to electricity? Electricity is the most form of energy that available. It provides light, heat, hot water, and the ability to run machines of all kinds, televisions, computers, fans, all the machines that use electricity to run. And most electricity must be produced by burning fossil fuels, especially coal, by using coal-fired power plant. So in US using coal-fired power plant for producing electricity from burning fossil fuels. How does the power plant work? In power plant, coal burns producing heat that boils the water into steam, and the kinetic energy of the steam drives the turbines, which drive a generator that produces electrical energy. So how we can save energy with catalyst? I told you before that the catalyst is used for speed up the chemical reaction by lower the activation energy. So the development of better catalyst has lowered the energy required for the chemical process. Using energy increases entropy. Every time we use the chemical energy to produce electricity and convert it to useful work, such as burning of the turbines in power plant, some energy is lost to the environment as a form of heat. This heat increases the entropy of the environment and cannot be reclaimed again. How we can improve the efficiency of the industrial process? So, because of entropy increases, no power or industrial plant can completely convert heat from the chemical reactions into useful work. So some waste heat will be found. And the efficiency means the amount of work that can be obtained from the process compared to the amount that must go into it. So, because we have some energy lost in the environment, not all the chemical reaction converted into useful work. So how we can improve the efficiency of the industrial process? The cooling towers are one way of transferring waste heat. So by using the cooling towers. So using cooling towers improves the efficiency of the industrial process. Now we have finished session 2 from chapter 20. I hope you understand the session well. And see you in the next session. Bye bye.